Okay. So I'm not going to go into the slide show mode. I'm just going to basically go through the slides here. Um, and, let's start with the talk. Everybody's kind of interested in Gen AI and, which is generative AI, and how does it help software engineering? And also with some research done of how generative AI is being used, code generative tools or any tool that generates code, uh, or the set of tools is the highest, uh, developed tool in the generative AI space. So most of the folks are kind of looking at how do they help software engineering, or how do they automate stuff wherein code automatically gets generated for a bunch of things. But the core functions of software engineering, where generative AI helps, is basically answering developer queries, right? And why do I say so is most of us who are developers, whenever we want to build something, we always want to kind of check out what is the latest and greatest, and is there a new algorithm, is there a new data structure that I can use to build what I'm building. So most of the development actually starts with, let me search how other people are doing things, how do they actually utilize certain concept, and what is the best way of doing certain thing. Like, for example, I want to create a dictionary of you know various functions in my code, right? Or I want to create a dictionary of employees so that I can use them for a different purpose. So how do I create a dictionary? So typically what people do or used to do before generative AI is go to Google or any search engine, type that in, get some Stack Overflow links or some documentation somewhere, read it, try to understand it, then map it to what you're building. Then, write a prototype code, see whether it works. After it works, kind of analyze the performance, and then you start actually implementing it where you require that implementation. Now, this whole thing takes a lot of amount of time. The reason being, you're trying to find a solution to your problem. You have certain constraints and you have certain requirements. But when you search, you get somebody implementing a dictionary. That dictionary might be storing something else other than what you want, right? So you typically don't get an answer. You get hints that you utilize to answer your question yourself. So what generative AI does is, because it has a lot of amount of data, or it has been trained on a lot of amount of data, which is available in open source. When you ask it a question like, how do I create a dictionary which is optimal in Python for storing employee records? It will actually give you a piece of code which actually solves your problem, like storing employee records. And then you can ask generative AI to modify it based on your requirements. So that is why generative AI or ChatGPT or other mechanics have become very popular recently, because software engineering, getting the answer to the problem that you have at your hand, has been challenging by using, search engines and so on. Right now, if you know what to ask, if you know exactly your requirements, getting a piece of code that runs has become really very easy. Okay. But before generative AI actually started providing this, there were few companies like, Microsoft, as well as Amazon and a few other guys, IntelliJ or like JetBrains for that matter, which were building, integrated development environments or IDEs using which you code, wherein they started supporting IntelliSense, or whenever you're typing something, like a function name, provide arguments and so on, so that you don't have to search through documentation, right? You immediately get the details and you can fill in the blanks. But then they started experimenting with, before generative AI, with normal machine learning and AI, can I actually complete the statement? So you might have seen Copilot, GitHub Copilot, and a few other tools which came out with a very basic thing that, I'll complete the line that you're typing. Or if you are typing a comment, based on the comment, I'll try to implement the code, right? So that is predictive completion, code completion, which is also good because when you are actually typing code, it helps you to type faster. It reduces the amount of mistakes that you can create. But at the same time, it may not actually provide you what you're actually looking for or what you actually want to implement. So you have to be very careful when you get a completion to basically figure out, is this exactly what I wanted to do or not? Okay. And with generative AI, the other things that have become very easy is for somebody who has recently joined the organization or has been in an organization for a long period of time, and he's been tasked with fixing a particular piece of bug in the code. Now, nobody knows the whole code, right? People come and leave the organization. So most of the times when you're actually debugging something or fixing some code, you need to get basic understanding of the code. So with generative AI, I can copy paste a piece of code and then ask generative AI, can you explain like in human terms what it does? Is there any issue out here that I need to fix? Are there any performance issues that I need to kind of look for? And it can analyze your piece of code or content and then provide you results based on the questions that you're asking. So in general, helps bridge the gap of understanding the code for new as well as existing engineers. And sometimes, we also forget what we have written like 10 years back. So we need to kind of go back and see, oh, this is what I'd implemented. I can modify this, for better performance today, but this is how I'd implemented it. And then, figure out the reasons behind it. So that is where generative AI actually has started helping software engineering. Even if software engineers are not using coding assistant like GitHub Copilot or Bitto or Code Whisperer from Amazon, as well as Replit has its own mechanics. They use ChatGPT or Anthropic's chat in one fashion or the other to actually help themselves. So that's why, even if, there are no tools, currently out there, which will say that, I'm the best tool out there, there are a bunch of tools, but people have started utilizing them to figure out what works for them and speed up their coding as well as, general understanding of development, right? Or software engineering as well as languages that they want to pick up. So let me go to some stats. This is the stats that we collected based on our tools usage and also from people who were willing to share their data, because privacy is a big concern in like generative AI. Like, what are you doing with my data? Are you basically training your models and so on? So, initially models like OpenAI, Anthropic, and a bunch of other models that came up were actually using users' data, but now they have an option. Do you want us to use your data or not? And, organizations typically, individuals don't care, but organizations typically care about data being private because code is their IP. But that said, looking at how people are utilizing these tools to help them in software development, what we figured out is most of the times people are, trying to get explanation for an existing code, right? 21% of the times. And they are writing or refactoring code 20% of the time, right? And then, debugging and code cleanup is another 15%. So if you kind of look at the general usage, more focus is on understanding the code that has been written, writing or refactoring and debugging, which means, people are adding new feature functionality or reducing issues in existing code more often than less. And then, there are also people who are trying to understand language concepts. Like, I know Go, but I don't know Rust, and the company is moving in that direction, or Rust is better for, writing a particular task. Then, I want to learn Rust. Initially, people used to go and, buy books and so on. But, the easiest way to understand a language is, hey, I'm doing this in Go. How do I write this in Rust? Figure out the differences, ask generative AI how to define a variable and so on. So you can start teaching yourself new language concepts or understand a new language and start programming in that language. So that is something that has become very easy now. So you don't have to depend upon books and so on. You can use generative AI as a coach and start to learn, new languages, new techniques, new algorithms, and data structures. Right. So, and this is a global average. Obviously, US, Europe, and other places, there is slight difference. What we've seen is senior engineers who are using it, use it like more, but give very precise questions which help in better answers. Whereas people or younger people who are just out of college or in college are asking generic questions, and then they have a bunch of interaction with generative AI to get the answer that they're looking for. Any questions here? Okay. So, for this, let me actually also show you, few tricks, or how generative AI works. Now out here, I already have ChatGPT open, and I have asked a very simple question: what is eco? Now here you have asked a question, what is eco, without any context. So it's basically giving you what term eco means, and it also tells you that eco also refers to command in technology and computing, but it has given you a generic answer for eco. Now if I give some context, how do I use eco? So here, it clearly means to generative AI that you want to use eco. That means, you're probably looking for how to use a command line eco on your machine. So it basically gives you these details of how to use eco. Okay. Now the interesting part is, after getting this answer, if I ask what is eco, it is giving me what eco means in terms of computing and technology. It didn't give me a generic answer, as you saw here, right? And the reason for that being is it maintains the context, right? So the conversation that you're having, it tries to maintain the context of what was asked previously, and now you're asking this question. So based on the question that you've asked previously, mostly you're kind of looking for what is eco in computing and technology. Now this doesn't happen automatically. What LLM models do is, they have APIs, and when you call the API, you have to make sure that you pass them all the details or all the questions that you've asked before along with the answer, so they have a context of what conversation was going on. And then using that, if you give the next question, they know that, okay, this was the previous context, this is the next question. So using the context before and this question, let me try to answer it. Okay. But out here, it is using generic knowledge. Okay. Now I can make AI change the kind of answer that it gives. Okay. So here, what I've given to AI is context eco is OHCE, right? Kind of an anagram. And then I say, using the context above and no additional data, answer the question without providing any explanation or mentioning the context. What is eco? So I've asked the question eco, but I've given a context that eco is this. So it gives me the answer based on the prompt that I've given. But in the prompt, what I've done is I've given the context. So I can give any context here, right? And I can change the answer that AI gives me based on the context that is given. Now, this is a very important concept, because whenever you're asking question to generative AI, if you say that this is the context, this is the information that I have, using this information and nothing else, don't use your any generic knowledge, answer the question that I have, then it will try to answer that question based on the context that you have provided. This is very important when it comes to code generators or usage of coding assistant built on generative AI, because most of the times people are trying to fix issues in their code. They are not interested in generic answers, right? So for example, if I have a piece of code wherein I authenticate with Google and then actually access some data, I've already written a function to authenticate with Google. So if I want to, retrieve data from Google, I need to authenticate into Google, for which I already have a function, so I don't need to write it. And after authentication, then I call an API to get the data. But if I ask a question to generative AI saying that, hey, I want to get this data from Google, it will write a generic authentication code so that you authenticate with Google, then you fetch the data. But when you are writing your code or implementing the code in your project, authentication with Google is already done. So you would like to call that function rather than having another generic function which authenticates with Google, because that will create like issues wherein you have like multiple places where you're authenticating with Google. To do that, you would want to provide the code that you already have within your code repository or source code as context to generative AI, and then ask a question that, hey, this is the piece of code that I already have. Using this piece of code, I want to implement, a data pull API from Google. Now, because you have given the context, using that context, it will provide you an answer. If you don't give that context, it will give you a generic answer. And if you get a generic answer, you take that answer and now you have to sit down and modify it so that it works in your code and you don't have a duplicate authentication function, right? But, if you can see here, if I provide the context, I can get answer based on that context. Now, this is a very important concept. And using this, one can actually utilize generative AI to answer questions based on their code or their data. Okay, and we'll just look into how is that made possible. So in generative AI, most of the times when you're kind of looking at Twitter or any information, around generative AI, OpenAI, Anthropic, and so on, you'll always hear the terms embedding, and you also have something known as fine tuning. So I'll basically go into embeddings first, right? Now, generative AI, the day it came out, you could converse with it using, human language or English or Latin or any other language that you have. But what it meant is you could do conversation, that is, using natural language. And for natural language processing, a lot of amount of research had been done before, wherein, for processing natural language, people used to basically convert a language string into tokens. Okay. And then figure out, like, for every word, what is the relationship of that word with the word adjoined to it, where that word can be used, and so on, so that using that you could basically answer back in natural language, or you could understand the semantic and context of the question that is being asked, right? And in generative AI, with the new model, which is known as transformer model, what happens is you take the language string or the sentence. And here I have a very simple example of, like, a sentence wherein I'm saying that every word out here is a token, and a token is represented by an integer. So I've just put like these words in an array, and then I'm saying that, the is represented by 1, mouse is represented by 2, ran is represented by 3, and so on. So you can take any piece of content and tokenize it. Now, here I'm giving a very simple example. In reality, it is much more complex, right? So now if I take two statements, the mouse ran up to the clock or the mouse ran down to the clock, right? And I tokenize it, rather than storing the words out here, I'm storing these integer numbers. And I create an embedding. Now, when I say an embedding, what it does is it actually goes through each of the word out here. And for every word, which is represented by token, I actually figure out the importance of this word with respect to other words in the statement. And I generate a vector, right? This is a numeric vector, wherein I have, probabilities of, like, how many times mouse will occur, like, ran will occur after mouse. Is mouse important? Is ran important? Or is clock important, right, in this particular statement? And I create these vectors. Okay. So first thing, what it does is transforms your text or code content into meaningful vectors. And these vectors are very important, because once I have these vectors, I can actually do a nearest neighborhood search. So if I search for something like ran, right, both of these statements will be in the nearest neighborhood or will be similar to ran, because, they have ran in it, as well as, it's basically, in the embedding index that I've created, right? If I search mouse, again, these two will show up. But if I have some statement which doesn't have mouse, then mouse will not be in the nearest neighborhood. So, those statements won't show up. So if I'm basically creating embedding, it allows me to search faster. But rather than searching for mouse as a string, I'm searching semantically for any statement, any string wherein, something similar to mouse is present, something similar to ran is present, or something similar to down is present, right? So allows me to search much more faster, right? And identifying semantic similarity. Why this is important? Because if I basically search for, hey, authenticate with a particular, API or library, say authenticate with, Google Cloud APIs. I say authenticate with Google Cloud APIs, but in your code, actually, you might have, OAuth, to Google. Now, OAuth doesn't mean authentication if I did a string comparison. But if I'm basically looking at semantic similarity, then OAuth is kind of authentication. If I'm searching for Google authentication, then OAuth with Google URLs might be something which is similar, and I can identify that. And this identification is very important because, the example that we saw out here, wherein I can provide a context and ask answer using embedding, I can find out based on the question, similar content, or, content which is semantically similar to what you're looking for, to generate context for generative AI, provide that context as an input, and then ask my question, right? So this helps in having generative AI understand the essence of the code, right? As well as capturing the context that you'd need to answer questions based on your own code. And you're kind of giving like a short-term memory to AI, right? Wherein in its memory, you're filling it with information that you need to answer the question. Okay, at a very high level. Any questions here? Yeah, I'll talk about this, Jim, as we go ahead later. So, just taking this concept, how would a code assistant actually allow answering questions based on your own code? So internally, there are a few coding assistants out there. You have Beto, you have, Cody from SourceGraph, and, other tools out there, which actually index your code. So what they do is, if you have a directory with your source code, for each file, they'll actually convert that file into chunks. Now, at a very high level, I'm saying chunks. You can do it based on lines, number of characters. But if you are basically doing it for programming, you need to identify the programming language and the constructs and the grammar of the programming language, so that when you're creating chunks, those chunks actually mean something. Like, it's a class definition, it's a function definition, it's a line, it's a statement, it's a variable definition, whether that variable is global, local, and so on. But the generic idea is, you take a piece of content, break them down. And why do we break them down? We break them down because OpenAI, or like, generative AI, Anthropic, OpenAI, Google's Bard, everybody actually has a limit on the amount of data that they can see and process or understand at any given instance of time. If you give any more data beyond that, they won't be able to process it. So for answering, I need to provide context, but I need to provide context and the question and get an answer. And I need to make sure that that all fits in the limits that are put forth by, the large language models or generative AI models that are out there or that I'm using. So that's why, break it down into chunks, so that, if I'm not able to give all the things that are related, I can at least pass, one or more chunks, get an answer, and then repeat the process on all the chunks that are semantically relevant to answer that particular question and get an answer over a period of time. So I take the file, I break it down into chunks. For each chunk, I'll create embedding. And then I'll create an index, right? So here you see an object, embedding vector, file name, chunk start, chunk end, and store it in a vector database, or any, in-memory storage also will work, wherein I can quickly do a nearest neighborhood search or cosine similarity to get semantically similar data points that I need to provide as context. And once I have this bit, answering question on your own data becomes easy, because what I do is, based on the question that you ask, I'll generate again an embedding, right? Using that embedding, I'm going to do a similarity search, identify the chunks from the index which are relevant to answering that query. Basically, all the chunks which are semantically similar, I'll collect those. And then using those chunks, I'll create a context to make a call to LLM. And then I'll basically call the large language model or generative AI model with the generated context along with the question that you have to get the answer to that question. Does this make sense? If there are any questions, please feel free to ask. Okay, I'll just show you an example of that. So here, we have indexed a piece of code, and I can ask a question: list all the files that need changes to add column description to table raw keyword data in my code, along with the code changes needed. So the concept that I just talked about, I'm just showing that concept in the works, wherein here I've given this query. It has already figured out the embedding for this, and now it is going through your code index and trying to generate the answer, right? So it went through the code index, figured out basically the files wherein raw keyword data is used, and then out there it is trying to add column description, right? So for folks who need to view it properly, I'm just increasing the font size, right? So it says, in your code, this particular file, if I open it, there is this particular table. Go and add this particular line, alter table. Then in this shell script, you have to go and then change this particular line, right? And then in a PHP file, you need to go and make other changes. Now, it was possible for generative AI to actually do this because it already had index based on the question. It actually went through the index, figured out similar items, then provided those similar items as context, and then using that context saying, solve this particular problem for me. But if I didn't have this, then I'll need to actually copy paste each and every individual file into the generative AI, which is ChatGPT or Anthropic or any solution you might have, all the files, and then actually ask the question. Now that is a tedious process, which is basically automated by your coding assistant, which might be available in the IDE or through the browser. And this is a very simple example of this. Now, one of the questions that Jim asked is, one feature needed for code generation in editor, right, is ability to modify the completion and redo all based on the given changes, right? The reason why this is not available, Jim, is a couple of things. It's not that it's not possible, but the reason why it is not available is because you need to have some kind of interaction to, look like, once you basically get these suggestions from your tool, the call to generative AI has happened and you have gotten like, 3 or 4 suggestions. Now, if you want to basically make any modifications to it, to the completion, then what you need to do is remember the previous question, remember the answer that has been provided to you, then understand the modifications that you're doing, and then update the completion, which is another back and forth with generative AI, wherein you'll need to remember all of this. Right now, the implementation in most of this tool is kept simple. You make a call, I give you an answer, and my conversation ends there. But in the future, you will see this kind of functionalities coming out. In Copilot, actually, recently in the beta version, They've also provided a mechanics wherein you can chat with code directly from your IDE rather than going to the chat window, which is basically an initial version of what you're looking for, not exactly the way you're looking for, but the initial version, which will morph into that as we kind of go ahead, because this is one of the functionality that is required by many people, because you get the suggestion, which is like, just there, but not perfect. And you might want to actually modify it and get an updated answer. Hopefully I could answer your question, Jim. Okay. So here, the concept that we talked about, wherein I'm constructing an index or I'm providing context to generative AI and then asking a question, is also known as RAG in the general world. But the idea is, if you want answers on a specific thing, try to generate context, provide that context to generative AI, and then get an answer so that it answers based on your data, your code, your documents, rather than providing you a generic answer. Another way to do that, right, which most of the people talk about, fine tuning, right? And fine tuning is not different from how the models were trained in the first place. So when we look at GPT 3.5, GPT-4, GPT-4, which is a collection of models rather than just a single model, and Anthropic, which has Claude version 2, you have Google Bard, they have Chat Bison and a bunch of other tools. Even Amazon has, a couple of LLMs. One thing is you can always provide context and then get an answer, or you can train the model itself, right? And where would I use fine tuning? I would use fine tuning if I want generative AI to respond back, in a specific way. So if you want to train behavioral aspects, like, in our organization, whenever we code, after every, before every curly brace, there is a space that needs to be given if you're writing in C, right? Now, that's your organization's rule. So any code that is generated should always do that. Now, you don't want to provide context for it all the time. That should be how the output is given. Then I'll fine tune, the generative AI model with a lot of amount of inputs, questions and answers, wherein it learns over a period of time that I have to do that. And then any answer it generates, it will always generate with those set of rules that it has learned, right? So fine tuning is like, adjusting precision of the model, right? But it takes a huge amount of time, right? It's basically specializing model to the specific task that you want to do. And for doing this, you have to train generative AI with a lot of questions and answers. So you basically pose a question, you yourself answer it, and you have to give both positive and negative answers and enough amount of question and answers so that the model over a period of time learns from those question and answers actually how it should respond, how it should answer a specific question, what is right and what is wrong, right? So it's basically like, taking a newbie, training him for 1 year, and now it starts behaving exactly how you want. So that is what fine tuning means. But it takes a long amount of time. And you have to basically give a huge number of question and answers as inputs so that, you can train this particular model to behave exactly the way you want. Most of the people want to just plug and play. You don't want like to use generative AI wherein you have a 2 MB repository or piece of code which is just 2 MB long, and then you're waiting for a day so that the model is trained and now it can answer questions on your code or your data. You typically want to use generative AI as soon as possible, the moment you have it, to answer questions on your data. So that's why people prefer embedding more, because it is quicker to get started than fine tuning. But fine tuning has its own usages. And, for bigger organizations or organizations wherein, rather than using open source APIs, they have wrapped everything up and they're basically creating their own set of APIs that they should use internally, and they don't want to use anything which is externally available. In that scenario, fine tuning is the best thing, because you don't want your model to answer on anything which is generic, rather answer it based on only your own data. So in that scenario, you can use fine tuning. And again, the other thing that people think, when they think about fine tuning is, why can't I use generative AI itself for fine tuning? Because I have to give a lot amount of question and answers. I can actually give my data and ask generative AI to generate a bunch of questions and answer them also, and use those set of questions and answers to train, the model. But, the main problem is if you don't have any human in between looking at the question and answer, if there is one mistake made by AI while generating those question and answers for fine tuning, that will be extrapolated when you basically get answers from the model. So, anybody in data science, kind of knows the amount of like preparation that goes in cleaning up data, removing biases and so on before you actually use it. The same thing holds even in case of generative AI. Any questions here? Okay. Now, we all talked about the benefits and what it can do, but there are some challenges with generative AI as it is available today. And obviously, as you can see, we had GPT 3.5, towards the end of last year. Earlier this year, we had GPT-4, which, blew everybody's mind. And, you have models coming out from various other companies also. And then we had restriction on the amount of inputs that you can give. So in GPT 3.5, you could give 4K tokens. In GPT-4, you could go up to 32K tokens. And then Anthropic, which is another company, came out with their model, which supports 100K tokens, which is great. So now I can give more input. But although the limits have increased on the amount of input you can give to these models, those inputs are again smaller considering the amount of data that you want to provide them, or data that you want the model to use to answer your question, which is your own data, right? Which you don't want out there in public, but you want to give it when required and get the answers, right? So that makes handling complex tasks difficult. Now, to give an example, say that I have an update of Node.js and I have my existing code on Node.js, version say 12, and or like Node.js version 8, and I want to go to version 12. There are a lot of APIs which are deprecated. There are a lot of new models that you would like to use, and you have to modify the existing code. Now, if I wanted to use generative AI and say, hey, I would like to move from Node.js version 8 that I'm on to version 12, can you make modification? Now that becomes a complex task because first of all, the generative AI model may not know about the new version if it is very recent, because it hasn't been trained on that. So you might have to provide the information on what all changed and how to make the changes to move over from version 8 to say version 12. Along with that, now you have to give the existing piece of code so that using the context of these are the changes required and your code, it gives you the answer. But with the limits that we have today, providing all of that in one go is not possible. If you basically say, I'll split it up, then the thing is, can the whole context of what changed fit into the request in the first place, right? That's one. The other thing is generative AI provides you answers, but is not able to do tasks. So you have to write other modules which will actually perform tasks. Like you cannot say to generative AI, create a file with this piece of code. It will give you code, but you need to actually go create a file on the file system, copy paste the code and save it. So, but there are tools being built wherein you can ask this, and there is a layer on top of generative AI which basically uses generative AI to figure out what the user wants to do, then isolates it, that, okay, you want to create a file, so I'll have a process outside of generative AI, which is actually creating the file, taking the output of generative AI and then putting it out there into that file. And there are implementations available like, Auto GPT and so on. But if you want to use it in real life, it takes so much amount of time for those systems to process and actually do stuff that it is impossible right now to use it in a production environment or in an enterprise environment. But that might change, 2-3 months down the line, 8 months down the line, those things will be common. But handling complex tasks is difficult. The other thing is the right balance between broad knowledge and specific advice, right? So sometimes when you basically, if I ask a question like, what is eco out here? It gave me a bunch of like answers and details, but I'm only interested in like technology and computing. It didn't know, and I was not very specific. That's fine. But it gave me a bunch of things that I don't need. Here, for example, I asked, okay, how to use eco, right? Again, I was not specific that, I'm using Windows, I'm using Mac OS or this thing, but, it gave me a bunch of things. Just giving me this information would have been good enough. So, they are not trained and they don't know how to answer. So they give as much information as possible, but sometimes, you don't want that when you're doing specific tasks. And we talked about the memory constraints. All of these generative AI models have a limit on the amount of input that they can process. And we always have more than those limits to use, right? So, all of these generative AI assistant tools and so on, they put a layer on top wherein, they try to shield you from these limits, wherein, they might break down your question or inputs into various segments, make multiple calls, get the answers, collect all the answers, then summarize it, and then provide you, a better answer at the top. But somebody has to write that. It is not directly available from generative AI. And that is where, these tools or assistant actually help you when they are writing this layer on top of it. The other big problem of using generative AI, and this, is very important, over reliance can basically lead to weaker coding skills, right? Like generative AI today can be utilized very well by programmers who are good programmers because they know exactly what to ask. They can look at the code and then they can basically say that, hey, I don't want to save this in memory, I want to save this in file, and so on, right? But if somebody who is weak at coding starts using it, then the initial thing that they see is, hey, I don't need to write code, I can just ask the right questions and I get code. So now when you get code, you basically save it into a file, compile it, run it, and you're happy that it runs. But the general understanding of why did this code work, why was it written this way, people forget, because it's very easy, right? If you don't put the hard work, it just works, then you forget the importance behind it. So over reliance can actually lead to weaker coding skills. So use it when required, use it as a helper tool, don't be dependent upon it. And then there are also challenges related to data security, right? If you're using models like OpenAI's GPT 3.5 or GPT-4, or Anthropic for that matter, or Google Cloud, every request that you make to get the answer, you're sending them an input, which might be a code, which might be a document or data within your document. Now, not all people are comfortable with it, but there are solutions wherein these models can be deployed on clouds like AWS, Azure, and so on, which might be specific to the organization. And you have Hugging Face, which actually has a lot of amount of open source models that you can deploy in-house to deal with data security. So there are solutions for that. But in general, if you're using commodity generative AI, then you have to make sure that for the accounts that you have, you say that don't use my data to train. The other piece that is very, very important and that we all have problem with is hallucination, right? So if it doesn't know, it will make up things, all right? So if you basically say, hey, I want to basically use an API which does semantic analysis to process my data and ask that question to generative AI like OpenAI and so on, it will give you an answer. It will give you a piece of code which looks like it will work, but it won't, because those APIs don't exist. So it might make up things, and you need to make sure that you understand that and check and verify before you use them. And these challenges over a period of time will be solved. These are the challenges today that people are already working on. Any questions here? Okay. So in today's world, as Jim also pointed out, and most of you guys who have been using ChatGPT or Copilot or Code Whisperer or other tools that are out there, all the generative AI solutions or coding assistant today basically support question answering in one fashion or the other, right? Code completion, error detection, right? Like if you run a piece of code, you get an error, you can provide it to generative AI, it will try to provide you an answer, right? As well as provide, generic understanding of code. This is what all the generative AI solutions today have started providing. But in the future, this will change because, generative AI is evolving and it can do far more better things than, just providing this. Now, this actually helps a software developer in day-to-day life to do a bunch of things, right? Speed up on coding, get answers, so now you don't have to spend, a couple of hours figuring out what is the right mechanics. You can get an answer, try it out, check for performance, and a bunch of other things, right? So this is what generative AI does today. Now, before you use generative AI, and most of the people, some people hate it, some people love it. But if you know how to use it properly, you'll like it. If you don't know how to use it properly, you'll hate it because it's like, it's never giving me the answer that I want, right? So to interact with generative AI, there are a few things, that we have learned, or, even I have learned in a hard-learned way, and, the term prompt engineering or prompt engineers have come up recently. But, the important aspect of that is you need to have clarity in your queries or, questions that you ask generative AI. As I kind of alluded to before, if I ask like, what is eco? It's going to give you a generic answer. It doesn't know the context why you're asking what is eco. But if you say, can you give me an example of eco CLI or how to use eco in Linux? Now it has more better context and it can give you a better answer, right? Similarly, if you basically ask it, give me a piece of code to do XYZ, it will generate code in its default language, like, that it uses, which may be Python in case of like OpenAI, which might be something else in other models. But if you want it in like, say, Node.js or C, be very specific with what you exactly want. So I'll give you an example out here, right? So this is Python-based inventory management system. Implement an inventory management system. So it gave you like, pretty decent code, cool, which will work, but does it really do what you want? Or you can basically be more specific by saying, implement an inventory management system to maintain inventory of items which has name, purchase date, office location, and can be assigned to users. Now it has few more details and it can give you a better answer. So the better question and the context you give and the information you give, the better answers you get. Now, the other thing which is very important is if you don't get the answer that you're looking for, try to give it hints. Like if I was using this, right, wherein I said, implement an inventory management system, and I saw this, it's just the name and the quantity. I want like, the office address and so on. So say, can you modify this piece of code so that I can have like, name of the item, quantity, office address, and few other things. And it will go and modify this piece of code rather than saying it doesn't work and give the same question with few more details again, because that is going to waste your time, as well as now, because all of these generative AI maintain context, they had some context. Now that context is, being corrupted with additional unrequired data, right? So always give feedback. That is the best way to actually, increase the efficiency rather than, just repeating the question or changing the question every time. Okay. Primary usage of this is, if I want to do a quick prototype, rather than typing code, if I have in my mind what I want to do, I can basically just type it out there, specific details, and get a piece of code, and then try it out. So for rapid prototyping and brainstorming, whether something works, doesn't work, whether it will run in production, what is the performance, so on, generative AI is really, really good, right? But again, as I said, there is hallucination. So always double check and verify the results. Don't assume that whatever code it gives is going to run without issues. And then the other thing is also verify whether it is actually doing the stuff that you want, because sometimes the code looks, really decent and you think it is exactly doing what you want to do with all the function names, but then you figure out the function implementation is not what you wanted because, some specific details were missing, right? So don't replace human judgment, right? Always verify, irrespective of however good it is, you'll still find some issues and you have to rectify that before using it. Any questions here? Okay. So, I'm heading towards the end of the presentation. So what does the outlook look like? So generative AI and coding assistants are here to stay. and they actually, we have done some analysis, and they help improve the productivity of software engineering teams by at least 30%, right? And, today, the way they can help in certain areas. They can't obviously go through all of your code because, even with the mechanics that we talked about, indexing and so on, if you are trying to get the answer quickly, you can only make one call to OpenAI or Anthropic and so on. And in one call, you can only pass so much amount of context and get, the answer. So if you want a better answer, you have to wait for a longer period of time, because then you have to make multiple calls, and people don't love to wait. So most of the generative AI based coding assistant right now are kind of looking at, how do I give quick results, so that, you can get started with what you're doing. Complete results is something that, all the generative AI solutions are working on, right? Because of speed limitations as well as processing limitations. Right now, we are kind of just looking at generative AI tools as, coding assistant in your IDE or on a web page somewhere where you can ask questions and get answers. But in the future, you'll have agents which do a bunch of things. Like today, when we, write code in an organization, and you're checking in your code, or you're basically making a pull request, somebody has to review this piece of code. And we wait a long period of time because nobody has time, right? Everybody is working on their piece of code. Whenever they get time, they'll review somebody else's code, or if somebody forces them. But that code review process can be completely taken over by generative AI, right? Wherein you can basically fine tune it based on code reviews already done for that particular repository. So it knows, what the code reviewers are looking at. Based on that, it can then start analyzing the pull request and providing feedback. Some of these tools, are there in alpha or beta version, and will get, much more better as the time goes ahead. So some of the things that, developers hate to do or don't have time, those can be automated using generative AI. So there is a tremendous potential out there. And it also removes human bias, right? So think about it. A junior developer joins into the organization, made a mistake. Some senior developer who reviewed his code is like, this guy, doesn't check for like null values or, initializes variables. And every time that guy checks in code, he's going to basically scrutinize. There's some human bias out there, irrespective of whether that issue is there or not. The user is going to scrutinize, like, hey, have you checked for this? Only then I'll check the PR, right? That might be the first review comment. But with generative AI, that's not going to happen, right? It doesn't have any human bias. It's going to look at the code that is checked in as a fresh piece of code, review, and give feedback, right? So a bunch of things can be automated as we kind of go ahead. A lot of stuff right now in development is like shift left, right? Security, let's shift it left. Privacy, let's shift it left. Performance, let's shift it left. Now, when we say shift left, what happens is, rather than actually figuring this out in the CI/CD process, or when the code is checked in and then fixing it, it's like, let's look for these few things when we are coding, and then fix it when we are coding itself, so that, it doesn't come up later. That is what shift left means. So now a developer, for writing a single line of code, has to spend 3 to 4x more time looking at all of these aspects so that he can code better, right? Because everything has been shifted left. You just piled up more work on the developer. Those kind of things, wherein the specifics, those can be automated by generative AI. Wherein, anytime you save a file, if you have to check for security and modify the code out there, if you have to do linting and a bunch of other things, all of those things can be taken care of by generative AI, so that the developer now can, focus on what is required to be focused on, which is the logic and the thing that is implemented, right? And in the future, generative AI is here to stay. It's not like, many people talk about it's going to take away jobs and so on. No, it's like an assistant. It helps you get better. It's not going to take your work away, but it is going to help you focus more on the things that you love to do and take care of the things that you don't love to do. All right. So the future outlook is, the tools will keep on improving. You'll see beyond these tools, agents which do things automatically and take care of things that, developers hate to do, like writing unit test cases. It's not that they hate to do, they don't have time, right? As well as, making sure that the code is more secure, is more performant, is following the documentation policies or organization policies. Even if you miss them, generative AI will handle them. So that's the kind of outlook. And as the models are improving, if you kind of see every 6 months, they have new data, the limits are being increased, performance of the models is increasing, the cost is kind of going down, you'll see, these tools actually evolving and being able to handle more data, give you more precise answers, and get better overall. So that's all from my side. Open to questions.
Yeah, there's any more questions? Can you answer all in Q&A?
Yeah.
Okay, great.
I think there are a few questions. I answered Jim. There is one, is fine-tuning always based on, RLHF? It depends, Jack. It depends upon the use cases that you have. So, if you're kind of tuning a chatbot, it will be different. If you're tuning for, coding, it will be different. So it is basically, I'll not put one model or one specific thing. It will be basically based on like, the specific use case that you're doing. What products have already done fine tuning for programming? Okay, so this is like you have tab 9 out there, which basically provides fine-tuned models. So they do two things. They provide an IDE extension plus fine-tuning specifically for your code, but it takes time. So they'll give you, the IDE extension, which won't be fine-tuned, but then they'll work with your organization, take your code, fine-tune a model, deploy that model within your data center or what have you, and then use that to provide the answer. So tab 9 is one, which is in that space, and others are moving in that direction. Frag is comparing embedding from database for context switching. Won't it slow down at some point in time due to large amount of data to compare? Absolutely, absolutely. So, that is where vector databases are being used, so that, you're not actually using a normal database. And if you kind of look at Pinecone and so on, with the amount of data, even if you give a large code base or document base, search results are in milliseconds. So there is like a lot amount of research going in that area also, because people have figured out that training takes a lot amount of time. So if you want to get started and get the value quickly, generating an index which is very fast accessible can actually give you n number of elements in the context, can look at like similarity score which is 80% or above, and it also depends upon how you index. There are few factors which go out there. All of that kind of help improve the speed, and they obviously keep some in memory and some on the disk. But as the data grows, if you kind of split it and you do divide and conquer, which most of these vector databases do, or people who are implementing solutions on top of it do, then it makes results faster. But there is some optimization that goes in out there. So hopefully that answers the question. Is Microsoft Copilot safe to use from intellectual property standpoint? Okay, so it's a tough question for me to answer because I'm in the same business. But that said, the thing is, all of these guys who are using, some kind of LLM model, us, Microsoft, anyone, some portion of your data is going to go to the model to get an answer, right? Now, if that model is not within your data center, there is always going to be a question about like, hey, is there a security issue? Is there an intellectual property issue? Most of the organizations will actually sign a contract with you if you're doing it at an organization level rather than an individual level, wherein they'll say, we assure you that we are not going to use your data for training, recording, logging, and so on. So I'd say that, if you're looking at it from the organization's perspective, you can talk to Microsoft. Probably they will support something like that. But, there is always a risk of intellectual property. And that's why most of the people are not using Copilot for that reason. That said, organizations are not allowing. Doesn't mean that software engineers are not. They're creating their own private accounts using their own personal laptops. We've seen that happening. But yeah, there is an intellectual property risk. But there are solutions available. So talk to the provider that you're going to work with, and if they have some, they'll provide you. Otherwise, they'll say let's pause till we have something. To give answers if I learn something new about the field, not coding, thing, more specific. But today I learned about the tip giving context. Could you give a few tips on further follow-up questions? Okay, so Alex, if, like, my email ID is anand.das@bitto.ai. In case, like, I think this is a longer conversation. So if you give me a couple of examples, I'll tell you, how to ask questions. How about generating tests? Tammy, yes, generating test cases is possible, and most of the tools out there today support it. It works in a two-phase fashion, wherein first, they look at the code, then they say identify the test cases, positive and negative. And after you get the test cases, then using the code, they basically say generate the unit test code. So those are available in Copilot and Bitto, and a few other solutions out there. And there are specific solutions which are only like, I'm not going to do it like online for developer, but I'm going to do it as a part of CI/CD process, wherein after your code is checked in as a part of PR, whatever has changed, they look at that piece of code and then offline generate unit test cases, which goes through, your QA verification before it's kind of checked in. So those kind of things are. How do we tackle privacy? So two ways to do it. Like, today, if you want to do it like quickly, at an organization level, because not everybody has like a personal AWS account, and AWS won't allow that functionality everywhere. But Amazon actually now provides Bedrock, and Azure actually also has the similar model. So does Google. So if you're using AI models which are hosted on this platform, what they do is they share the common data, the model data, so that you can answer based on generic data. But the inference system, which actually processes the input, provides you the output, logs anything for error handling and stuff. That inference system is deployed within your virtual private cloud that Amazon creates for your account. That way you're kind of privacy safe. But for that, you'll need to go work with AWS or Azure and so on, deploy the model. Once you deploy the model, you're for sure that your data is not leaving that particular VPC. Was the best generative AI? Are you asking about the model, Bob? I'd say if you're asking about the model, GPT-4 is still better than most of the models out there, and but it's costly, all right. But by changing the prompts that you're using and providing context and more specific guidelines for GPT 3.5, it can do a good job. You have Anthropic, which is good, but I'll place it in between GPT 3.5 and 4. Google Bard, or their Bison models have improved quite a lot, and do look at Llama. But if you're kind of like, today I want to decide one, go with GPT-4.
Great, Anand. Thank you for the questions. It's been a while. It was very great talk. I learned a lot, and I think more should have listened. I believe. Yeah, we could do something maybe more bigger event like that. Maybe in person. You're here already. Yeah. Thank you everyone for participating, and hope you enjoy the rest of the day for the people in US, people in Europe, rest of the night or other countries. Take care.
Thank you, everyone. Bye.